Welcome everybody. So the topic of my talk is what is a Bitcoin wallet and how does it work? So I'm not talking about like blockchain in particular and all that stuff. It's more about the wallet thing. The motivation comes from, the Bitcoin price is like rising. A lot of my friends are getting into Bitcoin, and I know no one really knows what a wallet is, how they can hold their Bitcoins and all that stuff. So I just thought I would give like an overview about that and then some technical details. So basically the talk is divided into two parts. First part is like non-technical, just like explaining stuff. And then the second part is more for people like who code and stuff and who might think what actually is happening under the hood. And so let's see if that works. If anyone has questions about the talk. Yeah, there's like a URL on the top. I think that's where you can submit questions and I can then see them here. So let's see if this actually works. There won't be a lot of content on the slides by themselves because I find it usually confusing and then people are just reading stuff. So it's just like keywords or headlines. But I can share the presentation in the end, and there you have like my speaking notes, and yeah, so there you can find more stuff. And yeah, I think that's it. Sweet. Part one. What is Bitcoin wallet? So definition, I couldn't really find a good definition what a wallet actually is. So I found things like a Bitcoin wallet is a software program where Bitcoins are stored. To be technically accurate, Bitcoins are not stored anywhere. So just like falsifying itself within like 2 sentences. Or a wallet is basically the Bitcoin equivalent of a bank account. It allows you to receive Bitcoins, store them, and then send them to others. You don't really need a wallet to receive funds. It's also not really a bank account and stuff. So yeah, all this kind of stuff didn't really apply. So I could name some features or functionality a wallet offers. But yeah, I couldn't find like a really good definition for it. So just some basics about Bitcoin, stuff you always hear and you might not really know what it is. There's always talks about like private keys and addresses and transactions and maybe unspent transaction output and your Bitcoin like balance. And I just tried to give like an overview about what that stuff is. So a private key, well, you don't need a private key to like receive funds in some way, but it's necessary to redeem the funds later and actually like pass the stuff on and do something with your Bitcoins. The Bitcoin address, it's a bit like a bank account number. So this is like your unique identifier where people like can send you money to. They don't really send money, but there's like an easy way how to see it. And your Bitcoin address is tied to your private key, so they have a relation. The Bitcoin transaction is basically a flow of coins in the Bitcoin network, and so you pay someone an amount of money, so you like pass your coins on. In the classical cash world, it's like you give someone a $10 bill, for example, and if you have to pay $5, then the other person takes the $10 bill and gives you $5 back. So the other person is doing the exchange. In the Bitcoin world, it's basically you take that $10 bill, like divide it by yourself and pay yourself the change money. So it's a little bit like different, like who does changing the money. So you do it by yourself. An unspent or a transaction output or an unspent transaction output. In a technical way, that's more likely like a dollar bill. So this is like a I would say it's like a potential of money you have and you can like pass on, which is like spending money. And you have like, in wallets your Bitcoin balance, but you don't really have a balance like the PayPal account. You have more like you have a collection of unspent outputs, and if you sum all these up, this is your balance. Is like the potential of money you can pass on. So it's similar, but in a technical way, it's a little bit different. So wallet types. Out there's like multiple types of wallets, and there's like 2 ways you can like distinguish them. The one is on the technical side, how the addresses and stuff, how the addresses, the private keys are managed and created, and I will come to that in a second. And the second wallet is like use the wallet. So Coinbase would be a web wallet. So someone has like a wallet there and gives you web access to it. You can have a wallet, which is like on your computer. You have a mobile wallet, which is an app on your phone. Internally, they're all the same stuff, but it's just where you have hardware wallet, which is usually like a small device. You somehow can connect to your computer, because then the private key, which is important to like spend your coins, should never leave the device. You have so-called paper wallets. A piece of paper is like, or you can print it, or you like you write down some words which you later can use to like recover your private key. Could give this paper wallet to someone, and then the other person could access the which were sent to that address, for example. And there's a so-called brain wallet, which is basically a paper wallet, but you don't write down the stuff; you just keep it in your head. The other kind of how you can distinguish it's like a single or multi-address wallet. Random keys are generated. If you send money, generate a single address, use that. If you want change, you can use the same address or generate it. You should always use a new one, but that's not necessary. And well, one smart person called, what was his name? Maxwell. He invented something called like a hierarchical deterministic wallet, or short an HD wallet. And this is how you can generate a lot of keys and a lot of addresses from like what people know. Like if you have used a desktop wallet, you have like these like 12 words you have to write down somewhat to recover your wallet later. So from these words, it's like a seed in the beginning. You get like, I don't know, you can access all the keys later again. And yeah, there's like two types of these. Like the type 1 is just you take a random string and generate keys from there. This kind of works, but the one he came up with is like more sophisticated, and that's the usual stuff where you just get these 12 words to come to this to recover your wallet later. Yeah, so before we get technical, some basic functionality, what a wallet does. So like the basic stuff every wallet should do is it should be able to generate keys for you. Based on these keys, the wallet should generate addresses for you for like receiving funds or for receiving change, for example, in transaction. That's not really necessary that you have a new address all the time, but it's useful. The wallet should track your unspent transaction outputs, the stuff I mentioned earlier, to like so you can figure out like what's your balance. And your wallet should help you to create, sign, and broadcast transactions, which is basically the thing you need to do to send money to someone else. And someone else creates transactions so you can receive the money. And some wallets have some advanced functionality, which is what they're nice to have, but not necessary for like the basic principle of working. Like they can generate QR codes for receiving money, so someone else just scans the code and like the address is there and the amount and all the stuff. They can show you transaction history, manage contacts, show you like all the coins you have, or convert your balance from Bitcoin to like euros, dollars, or whatsoever. So it's like these nice, but technically not. Yeah, that's basically like the first like general part about like what the wallet does and for what you kind of need it. And now we come to like the more technical part. It's a bit if you like do coding or like familiar with some stuff, it helps. Otherwise, maybe still interesting. As I said, usually all the wallets now are like this HD wallet of type 2. It's like the Bitcoin improvement 32. Someone wants to look that up. And so all the stuff I'm telling now is based on this. And cool, that does not work. This will be later in the presentation I share. There you can actually see the stuff. And this is basically on the very left side is like a random input that's called entropy. And from there You create a master key, which is the second square there, and from that on, you create like individual accounts, and from accounts you get like addresses. Why is that useful? So if you're a big company, you could create one master key, and then you could create for all the departments in that company. You create like sub keys, so they all can manage their own funds, but not the funds of the whole company. And you can like derive private and public keys. The private key to someone, he's able to like move money around with that key. It's like for departments, like a head of department could do this and generate public keys. With that public key, people can track funds which are moved around, but not actually move them. So that could be like useful for an accountant company. So the accountant could use that key and see like all the money which is moved around, but is unable to spend this money. So they can and on the very right side, you see like you can, with these keys, you can addresses, and this is if you sell something, you would give to your end customer where they would have to send the coins so that you can, I don't know, give them a game on Steam or a cup of coffee. So it's a long journey to from a key to a Bitcoin address in the end, and do stuff and actually send it around. So we'll break this down a little bit. I try to keep it too technically, but since there's a lot of mathematical and cryptographical stuff involved, it's very hard to like not be techy. In the beginning, so you have like these 12 words I mentioned. This is like your wallet seed, and based on that is like a so-called keyed hash message authentication code, short HMAC, and that's a cryptographic hash that you use to sign messages and stuff. And this is defined in the US Federal Information Processing Standard Publication 198. So if someone is interested in that, you can look this up. And this basically says you take these, you take a seed, which is these 12 words. You have a fixed key in the Bitcoin protocol, which is just Bitcoin seed. We'll see it in a second. And from there, you can always recover your wallet, even if your computer burns down. If you have written down these words, you can take your phone or a new computer and re-access your funds, which is quite important. Also, there's like the cryptographical basic called ECDSA for the private key, and that means elliptic curve digital signature algorithm. I just want to name it. The curve which is used is like the SEC 265K1 curve. This is what happens in the background is like cryptographical magic, but this is how you get like from some random numbers to other random numbers, which then to computers make sense in the end. And details about that you can look up yourself, and all the terms are again in the speaker notes, and then you can Google after this. So this is a little bit of code. As I said, you have a key, which is defined in the protocol as just Bitcoin seed. Then you create these, as I called, HMAC with the SHA-112 hash function, and out of this you get like a hash, and this hash is like 64 bytes long. You cut it in half, and then you have a so-called private key and the chain code. The private key is important for you, and the chain code is that you all these keys linked together, which means the head of the department can create a key, he can pass on to someone else and generate a public key, which is somewhat related to this key. You don't get the public key to the private key used before. I think if you do coding, this is somewhat familiar. And that private key is just like random numbers on your computer, but somehow you have to get there, get an actual Bitcoin. You can give to someone else or you can give money. And there's like 5 steps in total required to do this. And there's a lot of hashing involved. So I'm not sure like everyone like knows what a hash function is, but it's basically, for some comparisons, like a fingerprint, which means you can identify a human being by its fingerprint, but you can't recreate a human being from the fingerprint. So it's very easy to get like from one way or from one side to the other, but you can't reverse it. And that's like a basic principle of graphical hashing stuff. And yeah, what happens behind how the hashing works isn't really important. One way is fast, the other way is basically impossible. So this is how a private key looks like in human form. It's just an encoding of like bytes created with your words and the seed. With the elliptic curve I mentioned earlier, you get from a key to a public key. So the private key should always stay in your position, and you can give away the public key. So from the stuff before, you get a public key which looks like that. Yeah, just want to show it, like what happens behind the curtains. Then you take the public key, do SHA-256 that. Of the result of that, you apply another hash function. Why these are chosen, looked it up, and then you get like the thing in the middle, the RIPE MD 160 hash sum, and on base of that, you apply a so-called base 58 check encoding, which basically just does reformat the second hash. And the important stuff about base 58, for example, is it removes characters which are like easy to misinterpret. So a Bitcoin address does not have a 0, it does not have an O, it doesn't have, what is it, a big I and a small L, I think, because this is the stuff as humans, in some fonts, it looks very similar, so all of that stuff is removed. And other reason is, the address which comes out there is in a way that like email programs, for example, won't put in a line break in it, so they won't break it off. And if you just double click on it on a computer, like most computers just select the whole address at once. So it's to be more user friendly and introduce like less errors because there's money involved. And as I said, it's like base 58 check. There's also some check summing in the background to ensure that you really get a valid address. Yeah, and the result on the very bottom, that's a valid Bitcoin address. And to actually show that that's even true, like, oh shit, oh there we go. So I got these addresses from a website, and where's my mouse? Ah, there we go. So this is like an online blockchain explorer. So the address you see here, that's the same which was on my slide, and you can see that like some people donated some money to this address, like 31 in total. And there's like a QR code which identifies that address, and here you can see that people like send money to this address. And now my presentation is gone. Fuck. Oh, good. I don't have my. No. Where is it? Yeah, there we go. Sweet. All right, there we are. So that was basically the way how you get from a private key to a Bitcoin address you can use to receive money. And some more things, like how do you retrieve?
20 minutes. Just say.
Yeah. How do you retrieve your wallet balance? As I said, you have like these unspent transaction outputs. So it's like people send you money which you haven't spent yet. Your local wallet has like a local database where it stores all of these unspent transaction outputs, and it then goes through and like matches. Cool. These are like the addresses I manage for in the program, and this is all the coin or the outputs who point to these addresses, and then it just sums up the values. So this is basically how you calculate your balance. And another important feature is like transactions, because this is how you actually like send money around. This is like in 3 steps. You have to create this transaction, sign it, and broadcast it. Creating a transaction is basically done. This is how it looks like, but yeah, you have to. Yeah, it's like not readable. A transaction is just a data structure which says it has inputs and outputs, and this is like how we say which money should move to which wallet. The signing progress of a transaction is like a talk on itself. That's like quite complicated, and broadcasting a transaction is basically just forwarding this created and signed data structure to a node in the Bitcoin network, and from there it ends up in like Bitcoin blocks. And this is basically how it gets validated, and then it's like, then this is like the truth in the blockchain, and this is how you move the money around. And that's basically it.